Hi SQL people, welcome to another free tutorial from SQLmaestros.com. In today's demonstration, I am going to show you how to achieve performance tuning using partition level locking in SQL Server. Now what you see on the screen is the masterclass content that I delivered a few weeks back. We have this very popular performance tuning masterclass. We call it SQL Server Internals, Troubleshooting and Performance Tuning. It is a 40-hour program and we cover the breadth, very comprehensive coverage and the depth, which means lot of deep dive content. What you see on the screen here is the modules for that masterclass from module 1 to 14. And if you take a closer look at the module titles, you will see that we really cover the depth of SQL Server engine. Now for today's video, I thought why not take one of the demos from the masterclass, and also it helps me to promote the masterclass content a bit. Okay, so this was a live class that was delivered and it was recorded. So the so-called HD recordings of this masterclass is now available on SQLmaestros.com. You can log on to SQLmaestros.com, explore this masterclass recording, 40-hour program, all HD videos, and you can go for a lifetime subscription. That is the key highlight, maybe for next few days or weeks, not sure until when, but right now if you go online, you will see a lifetime subscription of this masterclass, which means once you subscribe, you can watch the videos, you can watch the content as many times as you want over the next few years. All right, and also there's of course discounts going on, introductory offers and whatnot. Okay, so that's up to you to explore. Let's go deep into today's demonstration, today's content. Let's talk about that, which is achieving performance tuning using partition level locking. Now, I sometimes get questions as to why do I talk about concurrency when we are discussing performance tuning. Now, concurrency is a very broad term. It's a huge topic, but let's just take a specific blocking scenario. When a user report or a user workload is blocked by another transaction, by another user, for this user, it is perceived as a performance problem, right? Business users would not know what's going on. Why is my query not responding? Why my workload or my report is not bringing results on the client? And it may be a typical blocking scenario, but the business user is unaware of it. So the blocking problem is perceived as a performance problem. It really is a performance problem. So that's why I cover concurrency from the perspective of performance tuning in our masterclass content. And today I am going to show you how you can achieve better tuning, better response time of your queries by a few tuning techniques which involves concurrency. Okay, let's jump right into the demo now. So I'm going to go into module 6, which is concurrency and transactions, and let's go into that folder number 4, which is tuning. And inside tuning, let's jump into partition level locking. Okay, partition level locking. What's the background about this? Sometime back, I think in SQL Server 2005, Microsoft introduced the concept of partitioning, which is physical partitions. A table, and let's say a huge table, a large table potentially, which is running into a few, even hundreds of gigabytes, can be physically partitioned. Physical partition, which means parts of the table can be stored in separate files and file groups. And that's a lot to do with manageability, less to do with performance tuning. But then under the hood, one of this hidden feature here is when you implement partitioning, let's say you have enabled partitions for a table and now this table has physical partitions, you have a technique here which is called as partition level locking, which means when a few rows are logged and when SQL Server decides to do lock escalation, which means hundreds of these row locks are escalated to a table lock, the entire table gets locked. But with the help of partitions or partition level locking, you can switch to partition level locking, which means instead of the entire table getting locked, only the specific partition will get locked. So let's say, just for the sake of discussion, you have a table with 10,000 rows, and let's say you have 10 partitions and each partition has 1,000 rows. Now you have logged a few records in the first partition, which has the first 1000 rows, let's say 5 rows. And for whatever reason, SQL Server decides to escalate those locks from row lock to table lock. Now, but because you have partitions implemented, SQL Server will not escalate directly to the table. It will escalate to that partition, which is the first partition, which means users can continue to access the data from the remaining 9 partitions. Only queries that want to read data from the first partition will be blocked. That's a beauty. That is a wonderful feature to enable better concurrency and to, of course, get better performance out of SQL Server. So this is what we term as partition level locking. Lot of lecture. Let's jump into the demo and see this in action. I'm creating a database called partition lock test. Let's do this. Okay, done. Let's use this database. I'm going to create a partition function. So the syntax for that is create partition function, and you give whatever name. My partition key, the value is the type of data is going to be integer, and I say as range right for values 10,000 and 20,000. So these define the boundaries. For example, 0 to 10,000 will be one partition, 10,001 to 20,000 will be another partition, and then 20,001 onwards, upwards will be the third partition. Range right, range left. I would ask you to go to Microsoft SQL Server online documentation and explore more about what range right or range left would mean. But just for the starters, range right here means that the boundaries, the boundary value will fall on the right hand side of the partition. That's to do a quick overview about the syntax. So let's first create an independent partition function. Let's do that. Done. Now you got to create a partition scheme, which means you have to tell SQL Server where do you want to store the data. So we create a scheme. That's the syntax, create partition scheme, the name of the scheme, and as partition cust.pf. So you got to link the scheme with the function. So here we are linking that this scheme is working for this function, and we say put all the partitions to the primary file group. Now this is the place here where you can distribute the data, multiple partitions to different file groups. Okay, let's do that. We create the scheme. Now we will create a table. So just for the purpose of demo, we create a simple customer table here, which has one identity column there, attribute called call A. Okay, we have call B also. So we have 2 columns out there. And then we say, this would create the table. Just suppose, let's say I ignored this and we just create a table this way. This would create the table on the default partition. But on the default, it will put the table on the primary file group. But now when I say on cust.ps, I am trying to tell SQL Server that, create this table with this scheme cust.ps, and the attribute that is going to be used as for the partition key is call A, which means now this table from its very birth is going to be a partitioned table with whatever number of 3 partitions as we saw the boundary. So here, if you just go and look here, how many partitions do we have? We have 3. 2 boundaries means number of boundaries plus 1 is the number of partitions that you get. So here, when you specify the scheme, you have now linked, you've joined all the dots, which is, let's go ahead, create this table. This is going to be created on this scheme, which means multiple partitions. Those 3 partitions will all go to the primary file group. And which column is going to be used for the partitioning key, which is call A. Is call A integer type? Yes, it has to be integer type because in the function you specified integer. All good. Let's go ahead and create this table. Okay, now let's go and insert some data into the table. Let's insert about 30,000 records. Just for the purpose of demo, let's go and do this. This is just going to take a few seconds. And now, while this insert is going on, let's talk a bit about escalation. I could have actually showed you this demo with few records, but the escalation logic in SQL Server that when you try to update a specific row, let's say you're taking an exclusive lock and you are locking a few rows, SQL Server will first, the granularity that we are talking about, SQL Server will first acquire row locks. Each lock requires resources. It requires memory. When you have a lot of row locks, then SQL Server may escalate so many row locks on a table to a table lock. Now, so many here, the threshold as per Microsoft documentation is 5,000. If you exceed 5,000 row locks, SQL Server may, I choose my word carefully here, SQL Server may decide to escalate so many row locks to a single table lock. So the entire table gets locked. That is where concurrency gets reduced. That is where SQL people, business users would perceive this as a performance problem, because when the entire table is locked, all those user workloads who want access to the data in that table are just waiting because they're being blocked by this table level lock. But now with the help of partition, it's not going to be a table level lock, it's going to be a partition level lock. Only that specific partition is going to be locked where that threshold has exceeded. That's the catch, that's the beauty. Okay, so number of rows inserted, all good. Now I will show you how many records we have. So just let's do select count from customer. Okay, just this much. So you will see about 30,000 records there. And we have 3 partitions. So here is a $partition function using which I can actually see how many records I have in each partition. Let's go and execute this. Okay, that's the number. With the help of this border value range right, left, we got about 10,000 in the first partition, 10,000 in the second partition, and about another 10,000 or more in the third partition. That's the number of data. Okay, now friends, let's begin the the climax part. Okay, there we go. So let's treat this user as user 1. We'll create another user which we'll treat as user 2. Okay, let's right click and do a vertical tab group. Okay, so on your right hand side is user 2 and on the left side is user 1. So let's go and update a few records from partition 1. Look at the predicate there where call A is less than equal to 9999. You know that this is this is the data 9999. So these are the number of records in the first partition. So when you do this update, this is a mass update. So you see we do a begin trend, but there is no commit or rollback, which means this is an in-flight transaction. So SQL Server would ideally SQL Server will take 9999 row locks. Let's do this. But the threshold is crossed. So SQL Server might escalate this to table lock. That's the catch. So let's go and execute this. Now, in connection to, let's go and check the number of locks. So I'll just put this here and let's go and execute this. And you will see that the entire object customer X, right? You will see here customer table object request mode X and grant. So the entire table is locked. This is what the catch is. Friends, I should actually be also showing you something, which is this really. Okay, let's do a very simple stuff. Okay, so I've rolled back. Okay, I've rolled back that transaction. So let's do a simple select star from sys.dm _tran _locks. Let's see how many records we have here. Okay, okay, let's do this. Will be a little more meaningful. Okay, how many locks overall? How many locks do we have? Just 5 locks in the entire instance, right? Now I'm going to run this again, but this time I'm not going to take so many records. Let's just take less than equal to, let's say 4,000. Okay, well below the threshold. Okay, let's fire this update. When you fire this update, you will see 4,000 records affected. How many locks? Okay, let's go and execute. Now you will see 4,015 locks out there, which means of course about 4,000 locks are our locks that we have taken with the virtue of this update, this mass update. So there are about 4,000 row locks. Now the catch here is, let's go and roll back. This is the point that I was trying to explain you about the escalation. Now I changed this to what we were doing earlier, which is 9999. Let's go this. Now the number of locks that we are trying to acquire is way beyond the threshold of 5,000. So will SQL Server now take 9,000 around row locks? No, it will take just one table lock because lock escalation has triggered. Let's go and execute this and you can see 6 locks out there, which means apart from whatever other locks that were there, just one table lock. The entire table is locked. Now, what does the user do? User 2, okay, let's go down here. So let's fire these three select statements from user2. What does user2 want to do? User2 wants to read data from partition 1, let's say where call is equal to 5000. This record, this value 5000 belongs to the first partition, this one belongs to the second partition, and this one belongs to the third partition. Now, because the entire table is locked, none of these select statements are going to work. They're all going to wait. So let's give this a try. The first one, waiting. Okay, let's stop the query. Let's try the second one, waiting. The entire table is locked. Third one, let's go and execute. Waiting. The entire table is locked. I can obviously show you sysdm OS waiting tasks, and I can show you that these are being blocked and they wanted to acquire a shared lock and they're waiting, all that stuff. But it's quite clear and understandable that yes, this is a typical blocking scenario. Let's stop this. This is where partition level locking comes into the picture. Right now, by default, this is table level locking, the lock escalation feature. The entire table gets locked when the threshold gets exceeded. Now, because the table is partitioned, let's roll back first. We are going to enable partition level locking. How do you enable that? We'll alter the table customer and set lock escalation to auto. Now, this might sound a little funny. All this while, wasn't it auto? But anyway, that's how the syntax is. Here, these are the different options. By default, lock escalation is stable. You can also disable it. Not a good idea. That's a conversation for another video. Now we are going to change it to auto, which means enable partition level locking. Let's do that. There you go. And now let's scroll down quickly and let's try this again. Okay, shall we try this again? Yes, we should. Let's go and fire this mass update again. Exactly the same piece of code. We're locking 9999 records. Let's go and do that. Number of rows affected. Now you want to read the data from the first partition. Now, with all the explanation and the lecture that I'm doing from the beginning of the video, you know that this select query should not go through because this data belongs to the first partition, and first partition, if we have enabled partition level locking, so these 9999 rows, so many rows have been escalated to partition level lock, which means this entire partition is locked. Let's go and execute this, waiting as expected. But here is the beauty. The select statement for the second partition and the third partition will go through. Let's give this a try. Try to read data from the second partition now. Let's go and execute. It works. Yes. Try to read the data from the third partition. It works. Yes. Now, just for the summary, recollect. When we say second partition and the third partition, this is the same table. All these three records are in the same table, but they are physically partitioned. So now partition 1, the first partition is locked. You can't read any data from that partition, but the other two partitions, you can read data from that. Concurrency is improved. Now your queries that want to access data from the second and the third partition, they are not waiting. So not waiting means better performance, better response time of the query. All right, friends, this is partition level locking. Lovely feature. One of those good things about partitioning, which is less talked about because partitioning overall is more of a manageability feature rather than a performance features. But you know, on the sidelines, you have these beautiful things inside SQL Server that you may want to explore. And this is something that might suit your scenario. But a word of caution here, don't try to implement partitioning just because you want this feature or you want this advantage of partition level locking. The best candidates for partitioning in general will be huge tables, the large tables that have millions of records, and you may want to implement the sliding window scenario, etc. Those, I mean, of course, I would want you to read a lot more about partitioning on SQL Server documentation and see if you have a good scenario where this could fit really well. All right, friends, so I'm done with the demo. Let's roll back the transaction. And yeah, that is there. I will, on my cleanup code, I'm not removing the database. Okay, I'll do that after the video is done. All right, friends, thanks for watching. Hope you enjoyed the video. Hope you have learned something new. Do share this with your friends and colleagues. And of course, do explore the masterclass recordings. And we might also be coming up with new masterclasses or another schedule of this performance tuning masterclass. A lot of content on SQLmaestros.com. Continue learning. Happy SQL. If you like the content, give it a thumbs up, subscribe to the channel, and click on the bell icon so that you're notified on new videos. Most importantly, visit SQLmaestros.com. There's a lot of SQL learning resources out there: video courses, master classes, lab kits, ebooks, blogs, hands-on labs, and a lot more. Follow us on Twitter @SQLmaestros and myself _Bansal. Last but not the least, do subscribe to our newsletters. See you soon in another video. Goodbye.